Another example on this problem, and with a simple theory that we did, is the following. Another exercise is find the general integral of the ODE y second plus 2y prime is equal to e to the power t. And so, as before, so we consider the associate algebraic equation, which is the equation with lambda. And so y second becomes lambda squared, and this y prime is lambda. So lambda squared plus 2 lambda equal to 0. So lambda 1 is equal to 0. Lambda 2 is equal to minus 2. Then the general integral of the homogeneous equation associated to this is C1 e to the 0t, so C1 times 1, plus C2 e to the minus 2t. Of course, C1 and C2 are arbitrary real numbers. Okay? This is the general integral of the homogeneous, so of the same equation for the left-hand side, but with 0 at the right-hand side. Now we have to guess a particular equation for that. And here the reasoning is simple again, since here we have an exponential. The exponential does not change if you differentiate it. So perhaps a particular integral can be found by using the guess. So for the particular integral, for a particular integral, we use the guess y p of t is equal to a e to the power t. Plugging it into the equation. We have, so nothing changes. This is a to the power, e to the power t plus 2 a e to the power t equal to e to the power t. So 3a e to the t is equal to e to the t, so a is equal to 1/3. Then yp of t is equal to 1/3 e to the t, and then the general integral we looked for, the general integral of the equation of the non-homogeneous equation, is equal to C1 plus C2 e to the power minus 2t plus 1/3 e to the t. Okay, and this is the final answer. And then we go to the Cauchy problem. The exercise here says solve the following Cauchy problem. Y second plus 2 y prime is equal to e to the power t. Y of 0 is equal to 0, so this is a second order differential equation, so we need a couple of initial condition. One is the function at a certain point, and the other is the derivative at the same point. So e prime of 0 is equal to e, for instance. And now we know that the general integral is c1 plus c2 e to the minus 2t plus 1/3 e to the t. So y general of 0 is c1 plus c2 plus 1/3, and we impose that it is equal to 0, while y prime 0 is equal to minus 2 c2 plus 1/3, which is equal to e. So here we have the system. So we solve the system, so we must solve the system. C1 plus C2 is equal to minus 1/3, and minus C2 is equal to E minus 1/3. So for instance, mixing the two equations, we for instance multiply the first by 2, so we have 2c1 plus 2c2, and then add the second equation, so minus 2c2 is equal to minus 1/3, 2 times is minus 2/3, plus e minus 1/3. So the result here is, there is a cancellation, so 2c1 is equal to minus 1 plus e, so c1 is equal to e minus 1 divided by 2. If I am correct, am I correct or not? However, the second C2 can be directly found by here, is minus E over 2 plus 1 over 6. So we have that the solution, which is only a solution by the theorem of existence of uniqueness, the solution to the given equation, to the given, Cauchy problem, is then y is equal to e minus 1 divided by 2 plus 1/6 minus e over 2 cos e to the power minus 2t plus 1/3 e to the power t. And so by solving this exercise, what we learned, remarks. So remarks. First, in some case, so to solve an equation like 1, second order linear equation with constant coefficient, first pass to the associated algebraic equation. That is lambda squared plus a lambda plus b is equal to 0. If the solutions are reals, so lambda 1, lambda 2 are real, which means that the discriminant is positive. I don't want to tell these trivial things to you. You are clever guys. Okay, if the solutions are real, then y gen home is equal to c1 e to the power lambda 1t plus c2 e to the power lambda 2t. Are real and distincts, and you do like that. Second, find, so guess a particular solution and apply the theorem that says that y gen is equal to y gen homogeneous plus yp. Okay, and this is solution. Third, a Cauchy problem always has only one solution, because linear equations satisfy the hypothesis of the theorem of existent and uniqueness. And moreover, we saw in these cases, and it is a general fact, the solution you find is global, globally defined on R, not only in an interval. So this is why it is so simple. 4, imposing the initial conditions results in a 2x2 linear system. Very easy. And now let us see how to remove this limitation. This is a limitation to be removed. Because this second degree equation can have solutions that are not real, and even if real, they can coincide. So let us verify this case by another example. So the chapter is, what if the solutions of lambda square plus a lambda plus b equal to 0 are not real and distinct? So exercise is the following. So y second plus 6 y prime plus 9y is equal to the t. So find the general integral. Okay, the associated algebraic equation, which is the algebraic equation associated to the homogeneous equation associated to that. So you have lambda squared plus, oh sorry, okay, 6 lambda plus 9, this is equal to lambda plus 3 to the square, this is equal to 0. So the two solutions are real, but they coincide. So y of t equal to e to the power, minus 3. E to the power minus 3t is a solution to the homogeneous equation y second plus 6y prime plus 9y equal to 0. But how to find a second linearly independent solution? It must exist, and it must exist. I could prove this, but it is quite heavy. But so the intuitive argument is that when you write a general integral of a second degree equation, you need the two arbitrary constant. And in order here for this construction to have these two arbitrary constants, you need the two linearly independent solution. So I give you immediately the answer. I don't want you to go into deep arguments, and very nice argument probably is found in old books of mechanics when you construct the solution using the theory of Jordan canonical form, and this is really nice. But here we don't have time, we don't have the instrument, so I give immediately the second linearly independent solution. So, so this is like a miracle. So the second linearly independent solution is y2 of t is equal to t e to the power minus 3t. So it is the same exponential, but it is multiplied by t here. So let us verify it. So we have y2 second plus 6 y2 prime plus 9 y2. This is equal to y2 second, so you differentiate y2 and you find e minus 3t, so 1 minus 3t, e to the minus 3t to be differentiated again, if I am correct, okay? Because when you differentiate, we have to do it plus 6, and here e to the minus 3t is a common factor. Then you first differentiate t, and here you obtain 1. Then you keep t and you differentiate e to the minus 3t, and so minus 3t. Good. Plus 9t e to the minus 3t. Okay, now differentiate here again. And e to the minus 3t here is gathered out, And here you differentiate inside the bracket, and you have -3. And then here, then you multiply -3 for this, and so you have again -3 plus 90 e to the -3t plus 6 minus 18, 6 e to the -3t minus 18t e to the -3t plus 9t e to the -3t. And you see that here you have -6 e to the -3t plus 6. So these two cancel. And on the other hand, you have 90 plus 90, 18 minus 18. So everything cancels, and this is equal to 0. And so you prove that y2 solution to the homogeneous equation associated to the ODE. So by the theorem on the structure of the general integral of a second order linear homogeneous equation with constant coefficients, one has the following, that y gen home, here you have two linearly independent solutions, so e to the -3t and t e to the -3t, and here you just put here C1 and C2. And this is the general integral of the homogeneous. Now, you seek the particular integral. Notice that here you have a polynomial. And when you differentiate a polynomial, you still have a polynomial. And here you could basically start from a third degree polynomial. From a third degree polynomial here, you gain a first degree polynomial and so on. But perhaps it is too much. Perhaps it works, or perhaps it is too much, because here, in order to have t here, it is sufficient to have a t here. Here you generate a constant, so perhaps a good guess, so to find a particular solution, we use the guess yp is equal to at plus b. It is dangerous to use higher powers, because here you have y. So if you use t to the cube, here you have t to the cube, which is not here. And there is no possibility to cancel it. Of course, you can use it, but then you find that the coefficients are equal to 0. So to find the coefficients, a and b, we plug the solution yp into the equation. And we get, so yp second is equal to 0, yp prime is equal to a. And so we get 6a plus 9at plus 9b is equal to 2t. So the system is 9a is equal to 2, which are the coefficient of the first degree, and then 6a plus 9b is equal to 0. So a is equal to 2 over 9, and here 12 over 9, which means 4 over 3, plus 9b is equal to 0. So b is equal to minus 4 over 27. Then a particular solution is yp is 290 minus 4 over 27, and ygen is c1 e to the power minus 3t plus c2 t e to the power minus 3t plus 290 minus 4 over 27. If you want to verify, I'm not completely sure of the computation, but of course C1 and C2 are arbitrary linear number. And so here we have so second case for what concerns the algebraic associated equation. If the solutions to the algebraic associated equation are coincident, of course they have to be real to be coincident. Why? Try to understand why. Then we have that so this is lambda 1 equal to lambda 2 equal to lambda. Then ygen of the homogeneous equation at t is c1 e to the lambda t plus c2 t e to the lambda t. Okay, and in the following video we will talk about the other case, which is the case with complex, or should we say, let us see it now? No, let us see it in the next video.